Hello, we're going to talk for a few minutes about solving linear equations by addition. In most generic form, this is equations that are of the form x plus b equals c. Note here that we do not have a coefficient, so our leading coefficient here is going to be 1. So before we start, let's talk about a few of our goals. Our top goal when we are solving these type of questions is to isolate your variable. What you want to see happen here is for the variable to be all by itself on one side of the equal sign. So what we have to do is we have to work to get whatever is added or subtracted from the variable moved from one side of the equal sign to the other. And we do that, we're going to move any constant. So in order to move the constant, what we need to do is we need to add or subtract. And this is the important part. We need to add or subtract whichever is the opposite. Okay? So basically what that means is if I have a positive, I need to subtract. If I have a negative, I need to add. Okay? There's one other thing I want to remind you of, and that is if we are combining like terms, and remember, a like term is the same variable raised to the same exponent. So if we're combining like terms, we are just going to either add or subtract the coefficients only. Okay? Coefficients only. Your variable is always going to stay the same whenever I'm combining like terms. That may not be spelled right, but that's okay. Okay, so let me talk about this for just a second. So that would be things if I had like 2x plus 3x. Well, we're just going to combine our coefficients. That's going to give me 5x, right? Okay, so that gives us enough background knowledge, I think, now to work a couple of problems. Okay, so here's the first problem we're going to work. T minus 5 equals 9. So the first thing to note here is that it doesn't matter what the variable is. Variable is simply some unknown value. You could use t, you could use x, you could use y, you could use smiley face, you could use pineapple. It doesn't really matter what you're dealing with. But I remember our goal. Remember that goal is to isolate the variable. So the goal is to get our t by itself. Well, in order to do that, we of course need to move this negative 5. Well, and we move any number, well, moving anything for that matter, moving requires that you do the opposite, either addition or subtraction. So here, I've got a subtraction sign. This is a negative 5. So the opposite of subtraction is, of course, addition. So I'm going to add 5. And if I do it to one side, I have to do it to both sides. That's the rule whenever it comes to adding or when solving these linear equations. Is if I do something to one side, I have to do it to both sides. So, of course, negative 5 and positive 5, those are just going to cancel out, leaving t by itself on one side of the equal sign. And then, of course, 9 plus 5 is 14. Now, I want to note here that we can check all of our answers. So I'm going to check this one. I won't check all of them because it gets a little redundant from time to time. But let's go ahead and check this. So we know that t is equal to 14, so all we're going to do is we're going to replace 14 with t. I'll do it in a different color here. So I'm going to take our 14, and it's going to be 14 minus our 5. This is just my original equation. And then, of course, 14 minus 5 is 9. So since we know that 9 equals 9, it checks out, and we know that we found the correct solution to this problem. Okay, second example here, very similar to the first, but there are a couple of things I want to point out. The first thing is that my y is now on a different side of the equal sign. See, up here my t was on the left side, y is on the right side here. It doesn't matter. If you're on one side of the seesaw, it's the exact same thing as being on the other side of the seesaw, and that's all an equal sign really is indicating that you've got balance. So really, there's no difference in this problem than that problem. Remember, our goal is to isolate that y. We isolate it by moving the number, and we move the number by doing the opposite. So since I have a positive 2 here, the opposite is obviously subtraction. So I'm going to now subtract 2 from both sides. and then of course these two are going to cancel, and that's going to leave y is equal to 10 minus 2, which is 8. Um, and I want to encourage you to go ahead. I'm not going to check, like I said, I'm not going to check every question, but I encourage you to go ahead and plug in 8 for y up there and just see if it checks out. Okay, this question is going to require just a little bit of additional information. Guys, remember your sign laws here. We're going to have a larger negative than a positive. Remember, anytime your signs are different and you're adding or subtracting, you need to subtract the two numbers and then keep the sign of the larger. So let's just work this one step at a time. So first, let's deal with our coefficients. So right here we have like terms. We have the x's, which are the same. We both are raised to an exponent of 1. So we've got like terms. So in order to combine these, all we're going to do is do the operation between the coefficients. So 12 minus 11 is, of course, 1. And that's just going to leave me with 1x, which we just write as x. Okay. But now, remember our sign laws. This would be the same as if I owed you $18, I paid you back $11. So 18 minus 11 is going to give me 7. But now remember, my larger number was negative, so since my larger number is negative, my answer has to be negative. This one didn't require any movement across an equal sign or anything like that, but it does require that you understand those sign laws. So if you have any questions on sign laws, send an email to your instructor, and they can give you a little bit more work on that. You can also get some sign law work in Chapter 8 if you want to go back and work through those sections. I'm sorry, Chapter 7, and then you can go back and work those sections. Okay, this one looks a little more complicated. Best thing I can say is don't panic. With any of these problems, don't panic. Just use what you know, do one step at a time, and then go from there. Now, we're dealing with decimals. Simple 4-function calculator will do decimals just fine for you, or you can do it by hand to the side. Either one is okay. What I would do first here is go ahead and combine these like terms. Notice I've got like terms. They're both n's. They're both raised to a power of 1. Well, 10.9 and 9.9, well, there's only one difference there. In case you don't believe me, we can come over here and we can do some manual subtraction. Well, 9 minus 9 is, of course, 0, and 10 minus 9 is 1, and 1.0 is the same as just saying 1. So I've got a coefficient here of 1, which we're just going to write that as n. So we get n minus 4.3 is equal to negative 9.6 plus 6.2. Now, exact same thing here. I've got a larger negative than I do a positive, so I'm going to have to subtract those and keep the sign of the larger. Now, I'm not working with a calculator, so I'm going to go ahead and do this long subtraction. So this is 9.6. I'm going to subtract from that 6.2. 6 minus 2 is, of course, 4, and 9 minus 6 is, of course, 3. But remember, my larger number is negative, so that's going to indicate that my 3.4 is going to be a negative number. Well, that's going to give me n minus 4.3 is going to equal negative 3.4. Okay, well, now we're to the point that we've got to isolate that n. Remember, that's my top goal. My top goal is to get that n by itself. We do so by doing the opposite. So, of course, this is a minus, so the opposite is plus. So I'm going to add 4.3 to both sides. Well, now, again, I'm not working with a calculator here, so I'm going to come out here and do it to the side. Remember, my signs are different. If my signs are different, I have to subtract. So 4.3 minus 3.4, I've got to do some borrowing here. That's going to be 13. Okay, that's going to give me 6, 7, 8, 9, so that's going to give me 9 here, and then 0 here. So I'm going to be left with 0.9, but we've got to judge. Was our larger number positive or was our larger number negative? Well, in this case, 4 is larger than 3, so my larger number is positive, so I'm left with a positive 0.9. So my numbers here cancel, leaving n is equal to a positive 0.9. Okay, last question. We're going to deal with that dreaded object we call fractions. this really isn't going to be that bad, guys. In this section, your denominators are always going to remain the same, but I do want to remind you, if we have the same denominators as we do in this problem, I always abbreviate that as denom, that stands for denominators. If I have the same denominator, then we're going to add the numerators, that's the top, numerator, okay? So we're going to add the top, but we're going to keep the bottom. You keep the denominator. Okay, so we're going to add the numerator, but we're going to keep the denominator the same. Add the tops, but keep the bottom the same. Other than that, this problem is going to be the same as every other problem that you've been dealing with. So, remember, I've got to get the w by itself. I don't have any like terms to combine, anything like that. I just need to move this 1/3, and I do so with subtraction. So, I've got a positive, so I need to subtract, and then I need to subtract. Well, 1/3 minus 1/3 is of course going to go 0. They're going to cancel. That's going to leave me w here, and I'm going to write this a little differently because I just think it'll make it look easier for you. This is going to be 7/3 minus 1/3. Now that's the 1/3 I just moved over. Well, remember, if I've got the same denominator, and I do, they're both 3, I'm going to subtract or add, in this case subtract the numerators. Well, 7 minus 1 is going to be 6, but I'm going to keep the denominator the same, so that's just going to leave me with 3. So that gives me w is equal to 6/3. Well, what should catch your attention here is the fact I can reduce 6/3. And if you're struggling with reduction of fractions, you can go back to chapter 2, work on some fractions there. I believe it's 2.1. That will help you with that. But 6 divided by 3 is, of course, 2. And you will always want to reduce that fraction if you can. Easy way to do that is just to factor this into your prime factorization and then cancel anything that's same on both the top and the bottom.